I'm going to explain a phenomena called gyroscopic precession. So when this gyroscope has this inner disc rotating at a very high speed, then it gets angular momentum, and then its behavior changes. So when you put it like here, like this, it doesn't fall right away as you expected, but instead it behaves differently. So I'm going to wrap a thread on its axis of rotation and then pull it to make it start rotating. Now let's rotate it and see how it behaves. See, it doesn't fall right away, but instead it rotates. I'm going to explain how the gyroscope works. It's a phenomenon called gyroscopic precession. Let's learn how the torque and angular momentum work. Suppose we have a rotating disc here. Let us use this simple diagram of a disk which is rotating. We will analyze the angular momentum on it and the torque, and then why the gyroscopic precession happens. If it is rotating in some direction, then I use that to know the direction of the angular momentum. So, and I use the right hand rule. So I wrap my fingers in the direction of the motion, and then my thumb will give me the direction of the angular momentum. So if this right here was rotating this way, then I would wrap my fingers in the direction of the object of the motion, and then my thumb will give me the direction of the angular momentum. So this will be the direction of the angular momentum, and its sign is L. Now let's talk about the torque. There is a torque on this object when there is gravity. Like, let's put a support here. So if this thing was not spinning at all, then it would fall, because this is clearly unstable equilibrium. So if there is support here, as you can see, it will fall over here. But as we saw it, it doesn't fall, but instead it rotates. There is an upward force here, according to the third law of Newton. Here there is an upward force, and also there is a force of gravity which is pulling downward this disc right here. So on this whole device, on this whole thing, there will be a net torque, because this thing tends to rotate this way. It tends to, because there is always the force of gravity downward here, and here we have a reaction force. So the way I know the direction of the torque is the same way as for the angular momentum. I curl my four fingers in the direction of the motion. As you can see here, I will curl it this way, because it tends to make the system rotate this way. So I curl my fingers in the direction of the rotation, and then my thumb will show me the direction of the torque. So if I do this, then the torque will look inside the paper. So this will be the torque will look there inside. since we have the angular momentum looking this way, and it will try to follow the torque, because angular momentum always tries to follow the torque, then it will tend to change its direction following the torque. Then it will result in changing the direction, therefore making the whole system rotate that way.